All right, we're going to be starting a new unit. It's going to be about right triangles and trigonometry. And the first section we're going to be talking about is the Pythagorean theorem. So what I want you to do is on a new page in your notebook, I want you to title your page today's date. So you're going to write today's date is Wednesday. And then today's date, so the 3rd of November, right? And then I want you to write the Pythagorean theorem, right? That's what we're going to be starting with in this section. All right, so in a right triangle, the square of the length of a hypotenuse is equal to the sum of the squares of the lengths of the legs. All right, what is that basically saying? We have a right triangle here. I'm not asking you to write this down, by the way. You do not have to write this down. I do want you to write the title. And I want you to draw the right triangle here. So what it's basically saying, remember hypotenuse is going to be our side opposite my 90-degree angle. That's from the last unit. And then we have our legs. And the formula here is going to be a squared plus b squared equals c squared. Now when we say the hypotenuse squared, that's going to be on one side. So my side C is going to be the side opposite my 90-degree angle. And A and B, and it doesn't matter which side, I can flip these two, but I have one leg is going to be A and one leg is going to be B. And our formula is going to be A squared plus B squared equals C squared. Right? So I want you to write this down. Right? So when we have the Pythagorean theorem, we also have really easy, quick ones that we can look at really fast. These are called our Pythagorean triples. So core concept is a Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation. What I want you to write is I want you to write Pythagorean triples, and I want you to write these list of three numbers. What basically this is saying is I can plug any of those in, and they're all going to work for using our Pythagorean theorem, right? So let's just use the first one as an example. Now remember, when we're talking about a right triangle, our longest side is going to be the side across from my largest angle. So in this case, my hypotenuse is going to be side 5. So I can just, from that, I can label the other two, A and B. So we have A squared, which is going to be 3, plus B squared, which is going to be 4, equals C squared, which is going to be 5, right? I'm just taking these numbers here, right? 3 goes in here, 4 goes here, 5 goes here. Okay. Now we're going to actually solve this. We're going to try and we're going to check to make sure that, hey, if the left side equals the right hand side, we're going to be golden, right? So 3 squared is going to be 9, 3 times 3. And then we have 4 squared, that's going to be 16. And 5 squared is 25. Okay. All right. So 9 plus 16, if we combine like terms, it's going to be 25. So we have 25 equals 25, and that's what we're looking for here. So again, you want to write Pythagorean triples, and you're going to write down these triples here. And I'm just going to erase these arrows so it's a little easier for you to read it in case you haven't gotten it yet. Make sure you have these written down in your notes. This part right here. All right, so our first example. So example 1, using the Pythagorean theorem, find the value of x. That's the first thing we're going to do. We're going to use the Pythagorean theorem to find our x, then tell whether the side lengths form Pythagorean theorem, right? So when we're talking about Pythagorean theorem, we need a right triangle. It only works in right triangles. We have a right triangle here. So my two legs are going to be the sides touching my 90-degree angle. So I'm going to call A as 5 and B is going to be 12. And then the side opposite my 90-degree angle is my hypotenuse, and this is going to be side C. So it's going to write our formula. We have A squared plus B squared equals C squared. So I'm going to go ahead and plug this in, right? So we said A is 5, so 5 squared plus B is 12, so that's 12 squared, and C is x, so it's going to be x squared. Okay? All right, from here, we're just going to solve. We're just solving. We have 5 squared is 25, and 12 squared is like saying 12 times 12, or 144, equals x squared, right? Again, we need to combine like terms now. So we're going to add 25 and 144. So that's going to be, let's go ahead and use this over here. I'm going to go ahead and pull up a Desmos window. We're going to do 144 plus 25, which is 169. So I'm going to go back really quick and write that out. So we have 25 plus 144 is 169 equals x squared. All right, we have that equals x squared. All right, from here, we want to get that x by itself. And this is saying x times x. And the way we undo a square is by taking the square root. So we're going to take the square roots of both sides, both the left and right hand side. And if we go back to my Desmos window and I type in the square root, and the way you type in a square root using Desmos, let me go ahead and close that window because I'm not recording my face today. As we open up our calculator at the bottom, you're right, show keypad on right below less than or equal to. We're going to use this button here. It looks like a little house. You're going to click on that. And inside the house, you're going to type out the number we just came up with, 169. And the square root of 169 is going to be 13, because what happens here is 13 times 13 is 169. Just to double check, right? Okay, so let's go back. So we have x equals 13. All right, so that's the first part of the problem. Then we want to tell whether the side lengths form a Pythagorean triple. So we have 5, 12, and 13. If you look back at our notes, that's going to be one of our Pythagorean triples, right? That's this one right here. Right, so it is a sorry, didn't mean to change slides on you. That is a Pythagorean triple. It's one of our basic ones. So it's going to be yes. 5, 12, and 13. Okay. All right, let's do another example. I want to find the value of x, then tell whether the side lengths form a Pythagorean triple. Now, right away, you should notice that x is not on my hypotenuse, right? Now it's just going to be on A or B. And it doesn't matter here, like you can put it on A or B, but it's going to be in a different spot. So again, my two legs are going to be A and B. And then my hypotenuse is going to be C. So we have A squared plus B squared equals C squared. So we're still setting it up the same way. We're just going to plug it in. A is 7. B is x, and C is 14. Okay, so I'm gonna use Desmos with this problem too, right? But we do know what 7 times 7 is. That's 49. If you don't believe me, we can go ahead and double check it on Desmos here. So 7 squared is 49. We have 14 squared is 196, right? Those are the two that we were looking for here. So equals 196. I'm just plugging them in. I'm going back to my Desmos window, right? We said 7 times 7 is 49, and 14 squared is 196, okay? All right, so again, now we're trying to get our x by itself, and it's saying 49 plus x squared. So we need to remove that 49. So we need to subtract 49 from both sides, so minus 49. X squared equals, let's go back over here. 196 minus 49 is 147. So I'm going to go ahead and write that. It's going to be 147. Okay? So again, we're left with x squared, and we're trying to get x by itself. So we're going to take the square root of both sides. So I'm going to use Desmos here. I'm going to take the square root. So I'm going to open up my keypad, and we're going to take the square root. Inside square root, we're going to write 147, and it's going to be 12.12. Right, I'm just going to round to 2 decimal places for this example. So let's go ahead and go back. So if we go ahead and look at this, we have x equals 12.12. All right. And this tells us right away that is not going to be a triple, so no triple. Because it's a decimal, right? And the special thing about Pythagorean triples is they're going to create whole numbers, right? They got to be whole numbers. If you look back at our definition here, the Pythagorean triple is a set of 3 positive integers. Integer just means a whole number. It can't be a decimal, can't be a fraction. All right, so I'm going to give you a couple seconds. I want you to try this one on your own now. Give it a shot. All right, so again, we have a squared plus b squared equals c squared. And remember, c is my hypotenuse, and then we can label the other two sides a and b. So we're going to have 15 squared plus x squared equals 25 squared. And 15 squared is 225. 25 squared is 625. We got to subtract those. So 625 minus 225 is going to be 400. So we're going to be left with, because we want to get this x by itself, so we're left with x squared equals 400. Take the square root, and x equals 20. So there's our x. Now these numbers don't look like it could be a Pythagorean theorem triple. Right? Remember, it's just, these are the ones that we started with, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. However, if you notice 3, 4, 5, if you go back, we can pull, I'm going to write this next to it. I can pull, they all have a common factor, a greatest common factor. 15, well, it's supposed to be 20, not 25. Let me fix that. 15, 20, 25. I can divide all of those by 5. So if I do 15 divided by 3, divided by 5 is going to end up being 3. And 25 divided by 5 is going to end up being 5. And 20 divided by 5 ends up being 4. So yes, this would be a triple. It would be a 3, 4, 5 triple, because it is a multiple of a 3, 4, 5 triangle, right? We're just scaling it up, right? That was our last unit. We're dilating up the triangle. It's going to be essentially the same. They're very similar. They are similar triangles, okay? All right, so we got one last example we're going to do. It's going to be this one right here, right? We have a skyscraper as shown below, shown to the right, with support beams, right? We have our support beams here. We have a support beam here and support beam here. Use the Pythagorean theorem to approximate the length of each support beam, right? So we have a right triangle. I know it's kind of hard to see it, but we have one right here. Let me go and highlight it. We have our little our crossway and the building, and then we have my support beam, and it's going to be the same thing on the other side here. But we do have a right triangle, so we can use our Pythagorean theorem to help us find the length of my hypotenuse here, right? So we have a squared plus b squared equals c squared. Let me go ahead and do this. Let's see if I can do this in orange if this pops up. Right, so this right here, this length is 47.57. This is going to be my A. And this length is going to be 23.26. That's my B. And my X is my C. Okay, let's plug that in now. We have A was 47.57 squared plus B is 23.26. I'm just getting it straight from the formula. And then we have X is my C is X, right? So again, we're trying to solve for X. This is like our first example that we did. So we're going to use decimals here because we have some decimals. It's not going to be a triple, obviously, because we have decimals here. So let's go over to, we have, I'm going to do parentheses, 47.57 squared. If you're having a hard time taking the square, right, you can hit the, on your keyboard, hit shift and the number 6. There's going to be a little caret symbol. It looks like a little, like an arrow pointing up. That'll get you the symbol, or you can just use a to the b power, or a squared, because that'll get you, I'll show you. You can do this, and it'll just write the 2, or you can write a to the b, and you can fill in the letter. So if you need to change the exponent, that's how you would do it. All right, then I'm going to hit right arrow and hit plus. I'm going to do parentheses, 23.26, close parentheses, squared. All right, so we have this number here, and we want to take the square root of that. And I want to take the square root of all of that. So what I'm going to do is I'm going to copy this right here. copy and paste. I'm going to take the square root of all this, and I want to make sure I don't round anywhere. So I'm going to take the square root of everything in here, and my answer ends up being 52.95. Right? So after everything is said and done, my answer ends up being 0.92. Right? So we squared both of these. We added them together. That left us with x squared equals 2,803.9325. I wanted to make sure I didn't want to lose anything with rounding, so I took the square root immediately, which is why we copied and pasted this whole line and took the square root. Okay. All right. Last example. I want you to try this one on your own now. The flagpole shown is supported by 2 wires. Use the Pythagorean theorem to approximate the length of each wire. All right, so first thing you should have done is you should have called the length from the pole to the wire A or B, and the height of the pole the other letter, right? So if you said that the 8.5 was B and your height of the tower is 15.1, you can switch them back and forth. That's okay. And then, but we do need to make sure that my x is my hypotenuse, or c. So let's just go ahead and do this. We're going to write a squared plus b squared equals c squared. So it's going to be 8.5 squared plus 15.1. That's the height of my pole, right? So we have our height here. This is the height right here. And we don't know what c is, right? So we're going to go and write x squared. Okay. All right. So if we're going to go over to decimals, I'm just going to write 8.5 squared is 72.25. And I want to add that with 15.1. So 15.1 squared, like so. All right, so it's going to be 300.26, right? And so from here, I want to take the square root of that. So I'm going to take the square root and I'm going to copy and paste all of this. Control C, put it right in there, and Control V, paste it in there. So the wire length is going to be 17.32. I'm going to flip that back over there. So X equals 17.32. Oh, 3233. Sorry, no, not 32, but 33. Because if you look at it, 8 tells me to round up, right? We have 17.32, 8. I want to round to 2 decimal places, so I need to fix that really quick. Let me erase my answer. It's going to be 17.33. Okay. All right. Well, that is the Pythagorean theorem. I want you to work on, in Delta Math, you have an assignment. It is going to be called M2, I think it was week 13. I think we're in week 13 now. Progress reports are going to be due this Friday. I'm not going to be including the test that we took last week, last Thursday. I'm not going to include the quiz because I haven't had time to come back to school and pick those up and grade them. If you have any questions about your grade, please contact me at my email. Email is all over the place. If you just go to Gmail with your student account and type in Siegel, my name should pop up if you don't remember my email.